Alright, so let's move on to the next one. And if you need to go back and finish filling out any of those problems, then please do. Alright, so what is the probability model for all of this? So what are our different options? We could have 0 successes, 1, 2, 3, 4, 5, 6, 7, 8, 9, or one more, 10. So we have 10 boxes. And we already figured out the first one, which would be 0.058. But how do we figure out what the rest of all of this is? So, and we also want to construct an appropriate graph for the probability model. So we'll do that all in the calculator. So let's take a look at what that would look like. So in my calculator, what I'm going to do is I'm going to make a list. So stat, edit, and in list 1, let's clear this out. And in list 2, we're going to clear that out as well. And in the first list, we're going to put all of our numbers. So I'm going to do 0, 1, oh, why didn't you like me? Okay, let's try that again. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Not 18, 10. And in list 2, we're going to run that. We're going to go up to the top of list 2. We're going to grab a binomial, so second bars. Binomial, which is near the bottom. Binomial PDF. This is just the point itself. And we're going to do our count, so 10, comma, the probability of success, which would be 0.25, comma. So what do I want to do? I want to know what it is at all of these values for L1, so I'm just going to hit second L1. And so that'll run the probabilities on each of these little guys. And we get them. So the 5 is sitting down here at our fifth spot, just like we were expecting, at 0.058. And when we want to construct, so you'd use that to fill in the rest of our chart. So our chart here, all these numbers, so 0.056 would be our first number, 0.1827. Now you notice that the most likely number here is, well, our expected value is 2.5, right? Well, 2 was 2.8 and 3 was 2.5. Now, the funny thing about the expected value of 2.5, the n times p, 10 times 1/4, it's not an actual value. So the most likely number is actually to get 2. The expected number would be 2.5, which again is weird because you can't get that number. So how do we construct an appropriate graph? Well, we can do that on here by turning our plots on and picking a histogram. But when you do this, you need to make sure that when you're plotting it here, it should look something like this. These will be all of our options at the bottom. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then over here is going to be probabilities anywhere between 0 and 1. But all the heights are going to be these heights here. So like I really only have to go like here, where this would be point, so this one would be 1 here, this would be 0.1, 0.2, 0.3. And I can just pull them directly off of this. So if you wrote down those numbers, 0, 5, I'm trying to remember what the numbers were, but if you wrote down those numbers, you can just make your little boxes here, but it'll look like a histogram. And the precise histogram, the only thing I need to do is I would make sure I go from 0 to 10 by ones, and I make sure my y min would be 0, and my y max would be, let's say 0.3, because I know that it doesn't go anywhere above 0.3, and I get that, which is annoying. Let me clear these out. And let's hit zoom 9 just to see kind of what we see there. And we get this, but of course I don't really want them to go by 2.5s. I want them to go by 1s. What in the world are we plotting here? Second y equals. Let's go back on here. Ah, here's the problem. So when we go into this, I have my x list is L1. thing I have to do is I have to make sure my frequency is my list 2. That's the problem. So I have frequency in list 2, right? So that's all of our probabilities. Now, let's just hit graph right now and see what we see. Quit out of here, graph, and now we get that graph the way we expect it to be. So we need to make sure our window, I don't want my y max to be 12.5, I want it to be, I'm going to say 0.3, right? So the graph. Alright, what the heck's going on here? Oh, jeez. My x max is 10. Sorry, guys. My y max, so my y min is 0. My y max would be 0.3. And let's make our y's go by 0.1. So as you can see, you probably would have done better by just graphing them yourself. But yeah, there we go. And if you want to figure out the actual heights, you can just trace it across them, just like we did before. So it's a little bit different when we make it this way because we have to make sure our frequency list is our L2. And the other thing you kind of see is we can still do stat, one variable stats, and I do L1, comma, L2, because this will tell me that averages the 2.5, and it'll also give me my standard deviation, which we haven't really talked about how to do yet. Alright, so what I want you to, I'm going to leave you with today is try to think about this question, number 14. What's the probability that a student will guess at most 2 questions correctly? So this at most is a much trickier question. So the probability that you get 2, that's what we've been talking about so far. So that would be 10, choose 2, and then we would have to have 2 successes, 5 to the 2, and then we'd have to have 8 failures, right? So 0.75 to the 8th. But how does it change if it's at most 2? So that's what we're looking at. We have to try to figure out what happens when we try to figure out less than or equal to 2. So if you still have more time left in class, which is probably going to be pushing it at this point, this video may end up running out past the time and you might end up finishing this kind of for homework. So if you still have more time, I want you to try to figure out how to do number 15 and calculate this. Now you can use the chart that we created before, but how would you do that from scratch so we don't have to recreate everything? And then 16 kind of tells you how to do this with the binomial CDF. So try that on your own by hand, then try using the calculator step and see what you can do. So there's more time, keep going through the notes and try your best to figure them out. In other words, we're going to cover this on the next day.